The air on this August day in 2025 is electric with anticipation. On a 100-meter track, two machines stand ready for a historic race. In one lane, Boston Dynamics WildCat, industrial, powerful, built for speed. In the other, a sleek new Chinese robot dog, representing a different vision of high-speed robotics. WildCat is all exposed hydraulics and roaring energy. The Challenger is quiet, aerodynamic, almost biological in its design. The contrast is striking. Raw American power versus refined Chinese precision. The robots are still, but the tension is palpable. The hum of electronics, the hiss of hydraulics, the silent promise of electric motors. Teams of engineers watch, years of work distilled into this moment. This isn't just a race, it's a test of two philosophies, two futures. How fast can a machine with legs run? How do you balance power and control? The answers could change everything from disaster response to planetary exploration. Today, on this strip of asphalt, we glimpse the future of robotics. All that matters now. Which machine will cross the finish line first? The world is watching. The starter's pistol cracks. The race begins. WildCat explodes off the line, its engine screaming, hydraulics pounding the track. The crowd erupts, thrilled by the raw, animalistic power. Beside it, the Chinese robot dog launches forward almost silently, a high-tech whir, a blur of smooth, calculated motion. WildCat's start is violent and dramatic. The Challenger's is precise and efficient. The stadium is split, cheers for brute force, gasps for silent speed. WildCat's legs thunder, each stride a display of mechanical might. The Chinese robot's footfalls are rapid, light, a staccato rhythm of efficiency. Every sound tells a story. WildCat's pounding is primal, the Challenger's whirring is futuristic. WildCat's gallop shakes the ground. The Chinese robot glides, barely touching it. The difference is mesmerizing. Old-school power versus next-gen control. For the first meters, WildCat surges ahead, but the Challenger is right there, relentless. The crowd senses this is more than a race. It's a battle of eras. Every step, every sound is a glimpse into the future of machines. The race is on. The first seconds are chaos. WildCat surges with explosive acceleration, its legs churning, its body fighting to stay upright. It lives on the edge, every stride a balancing act between power and control. The Chinese robot dog, by contrast, accelerates smoothly, its software delivering power with surgical precision. WildCat's engine roars, its gallop a blur of force and instability. The Challenger's trot is steady, each step calculated for maximum efficiency. In the first 10 meters, WildCat hits nearly 15 miles per hour, a feat of engineering, but not without risk. Its bounding gait gives it speed, but every landing is a test of its sensors and gyros. The Chinese robot is just behind, its acceleration linear, its feet always in contact for stability. No wasted energy, no drama, just relentless, controlled speed. Two machines, two strategies, one wild, one precise. The race is neck and neck. WildCat is a marvel of hydraulic engineering, powered by a methanol engine driving high-pressure actuators in each leg. Its unique galloping gait mimics a cheetah, launching itself forward in explosive bounds. The onboard computer coordinates thousands of movements per second, keeping the robot upright and fast. But this power comes at a cost. WildCat is loud, inefficient, and requires constant maintenance. Its energy is lost as heat and noise, and its hydraulic system is complex and heavy. On the track, its initial burst is unmatched, but instability is always lurking. The robot's torso rocks with each stride, a constant battle against gravity and inertia. WildCat's philosophy: win with brute force, even if it means walking a tightrope of control. It's thrilling, it's violent, and for years, it was the king of speed. Today, we see both its strengths and its limits. The question: can raw power hold the lead? The Chinese Challenger is a new breed, each joint powered by its own high-torque electric motor. Direct drive actuation means instant, precise movement. No gears, no hydraulics, just pure control. Its lithium-ion battery is lightweight yet powerful, enabling bursts of speed without the noise or heat of combustion. The robot's software uses predictive algorithms, constantly simulating and adjusting every step for perfect balance. Its stride is shorter but faster, each step placed with surgical accuracy. There's no wasted motion, no side-to-side wobble, just forward momentum. The result? A machine that is quiet, efficient and stable, even at top speed. It's less about brute force, more about flawless execution. Every movement is deliberate, every watt of energy used for speed. Watching it run is like seeing the future, precise, controlled and relentless. The challenger is closing in. At the 50-meter mark, the race's core philosophies are on full display. WildCat leads, its early power advantage still holding, but the gap is shrinking. It's running at its top speed, 28 miles per hour, a testament to its design. But the Chinese robot is accelerating, now reaching 30 miles per hour through perfect coordination of its electric motors. WildCat's gallop covers more ground per stride, but each leap is a moment of instability. The challenger's rapid, controlled steps keep it grounded and efficient. WildCat expends massive energy just to stay upright. The Chinese robot simply runs. It's muscle car versus electric supercar, power versus precision. The American approach, solve with force and complex control. The Chinese approach, optimize every element for seamless performance. Two visions, side by side, racing into the future. The lead is shrinking, the outcome is uncertain. At 75 meters, the race shifts. WildCat's power is fading. Heat and violent motion are taking their toll. Its gait falters, the side-to-side rocking more pronounced. The onboard computer struggles to keep up, but physics is winning. The Chinese robot, built for endurance, is just hitting its stride. Its electric motors stay cool, its predictive software keeps it perfectly balanced. The challenger's form is flawless, its rhythm unbroken. WildCat's brute force, once an advantage, is now a liability. The Chinese robot pulls even, then ahead, first by a nose, then a full stride. The crowd holds its breath as the new leader emerges. WildCat burns fuel and energy at a punishing rate. The challenger is efficient, cool, relentless. The sound of the race changes. The whir of electric motors overtakes the roar of combustion. It's a symbolic moment, the future overtaking the past. The gap widens. The new era is here. The final 20 meters are a showcase of engineering at its limits. The Chinese robot dog leads, every step a model of precision and control. Its algorithms make thousands of adjustments per second, maximizing speed and stability. WildCat fights on, its engine screaming, hydraulics straining, refusing to quit. The crowd roars as the Chinese robot crosses the finish line, a new world record. It slows smoothly, cooling fans whirring, the new champion standing poised and silent. WildCat finishes seconds later, stumbling but unbroken, a legend to the end. Two robots, two eras, side by side on the track. The race is over, but the meaning is just beginning. This was more than a contest. It was a turning point. The future has arrived. The Chinese robot's victory is more than a win. It's a paradigm shift. For years, hydraulic power ruled high-speed robotics. Today, electric precision takes the crown. The implications are huge, quieter, more efficient robots for everything from security to healthcare. Energy efficiency means longer missions. Silent operation opens new environments. Precision software enables delicate tasks and safer navigation. WildCat's legacy endures. Brute force still has its place. But for speed, agility, and endurance, the future is electric and software-driven. Innovation will accelerate as new teams chase this breakthrough. Today wasn't just a race, it was a test of ideas, a leap forward for robotics. The silent victory on the track will echo in labs worldwide. The future of robotics is here, faster, smarter, and just getting started.